Alright, we're now doing some Chapter 3 material in Excel. So we're still working with the same file. I've added a couple questions since the last video. So we're going to work on question 7. So using miles per gallon, we want to sort the data and then calculate the mean and standard deviation, calculate a 5-number summary, create a box plot, determine if there are any outliers, calculate the range and interquartile range, and then calculate z-scores for all of the data values and determine if there are any outliers. Okay, so to do this, let's go ahead and create a new tab. So come down here to the bottom, click the plus sign to create a new sheet, and let's move it all the way to the end. Let's title it 7. Okay, let's go to our data tab. We want miles per gallon, so let's go ahead and select this whole column, click copy, and then paste it into this file, or into this tab. Okay, so we want to do a few things. The first thing we want to do is sort the data. Let me zoom it in a little bit. So to sort, you can just select the data, and then we want to come up here to the Data tab, click Data, and then we want to use the Sort button right here. So I'm going to click Sort, and then I'll just hit, it's set to smallest to largest. If you want to do largest to smallest, you can do that. Let's hit OK. Alright, so now we have the smallest down here at 10.4 to the largest of 33.9. Okay, so we wanted to calculate the mean and standard deviation. So let's do that. So let's do mean and standard deviation. I'm going to extend this over a little bit. Okay, so we already know how to do the mean. So in this cell, I'm going to say equals average, and then I just select the data I want to take the average of, so I'm going to select our data and then click enter. Remember we calculated this average in a prior video. If you go back to our data, we had an average of 20.1. Okay, standard deviation. So now for this, we're going to do equals STDEF or V, and then we want the dot S. Notice that there's a dot P and a dot S. This one's for population. This one is for sample. We always want to use sample. We're never going to use the population. So standard deviation dot S. And then we just highlight our data and enter. We get 6.026. I'm going to go ahead and bold these. I don't want so many decimal places, so on this home tab, I'm going to move this to number. And then if we can modify the number of decimal places with these buttons right here. So let's do 2 decimal places. Okay, we want a 5-number summary. So the 5-number summary includes minimum, first quartile, the median, the second quartile, the third quartile. Median is the third quartile. And then we want the maximum. Okay, so for minimum, let's do equals min, so min, open parenthesis, select the data you want, close parenthesis, enter. 10.4. Okay, well that makes sense because 10.4, after we sorted it, 10.4 is the smallest number, which is why it's on top. Q1, so equals quartile, so Q-U-A-R-T-I-L-E. So I want quartile, and then you just select the data, comma, so then it's asking which quartile do we want, 1, 2, 3, or 4. Well, we want 1, right? So we'll just put 1, close parenthesis, enter. Again, if you ever want to see how I did this, just click on the cell and then look up here and you can see exactly what I wrote. Okay, median equals median, and we select our data. We get our median. We also could have done the second quartile because we know that the median is the second quartile. So if I use the quartile function, and then this time using 2 instead of 1, we get the same thing. So you could do it either way, median or quartile. So equals, we want the third quartile, so I'm going to do quartile. Select our data. Which quartile do I want? 3, so I put 3, close parenthesis, enter. And then finally the maximum, which we already know to be 33.9, right? We know it from down here. Let's use the max function, equals max, open parenthesis, select our data, close, enter. We get our max of 33.9. Okay, I'm going to pretty this up a little bit. So let's go ahead and center this. Use the center button. Let's put a line in between. So I'll use the bottom border button right up here. And then how about we wrap it in an outside border. Or another thing we can do is we can right click, go down to format cells. Then you can specify exactly what you want. So let's say I want borders going across and up and down. But then here I'll use this, instead of using this boring one, I'll use the double. And I'll put that on the outside. And maybe let's bold this, give it a little color. I'll do some light blue. Let's give it a title. So I'm going to select these cells, use merge and center, and let's call this 5-number summary of miles per gallon. Okay, and we have our 5-number summary. I'm actually going to move it down just a little bit. So, I mean, I went a little above and beyond to like make it a little prettier. If you want to do that on the homework, I would probably be willing to throw a few extra points. If you can make my job easy to grade by making it very pretty and to the point, yeah, I would be amenable to some extra credit there. But let's also make sure we have a consistent number of decimal places. So if you want extra credit, make sure that everything is perfect, so they all have the same number of decimal places. So mean, standard deviation, we wanted the range and the inner quartile range. So let's bold these. So the range, so we know that the range is the max minus the min. Okay, so 23.5, and then the inner quartile range is the third quartile minus the first quartile. And there we go. I'm going to move this back up so it's all tidy and close together. Okay, so we've done mean, standard deviation range, inner quartile range. We've done our 5-number summary. How about we do a box plot? So I'm going to select our data, do insert. So we want to use this button, the statistical button, use box and whisker. So here, let's just call it box plot of miles per gallon. Let's make this a little bigger. Let's make this a little bigger. I'm actually going to delete this down here, this axis label. So let's just like recall that when we, where was it? Here it was important that we labeled what this was, because like this x-axis, because we had two different values, manual and automatic. But I'm okay not putting y-axis title, because it's kind of implied within our title for the plot. Whenever we say box plot of miles per gallon, we know that this represents miles per gallon, so I'm not much of a stickler there. So same here. So we don't really need to give it an x-axis because it's obviously miles per gallon. We're not breaking it down into groups, it's just the one. And we kind of know that these numbers represent miles per gallon because that's what we have here. Okay, so our minimum should be 10.4. Our first quartile should be 15.4, thereabout. The median should be 19.2. This is the mean, which is 20.09. That little X, if you can see it. Yeah, this would be the third quartile, 22.8, and then the maximum, 33.9. Okay, and note that we don't have any dots like down here or like up here. This is containing, the whiskers go all the way out to the minimum and the maximum. There are no individual dots on this plot, therefore there are no outliers according to the box plot. Okay, and then we wanted to calculate z-scores. So let me give a column to z-score. Okay, so recall that the z-score is the x value minus the mean divided by the standard deviation. So let's go ahead and do that. Equals mean minus, or sorry, x value of 10.4 minus the mean, 20.09, divide by the standard deviation. Okay, so this number is not right. This is like a massive number. We know that most z-scores are going to be between -3 and 3. So I need to add some parentheses here. So let me add parentheses around the difference. So again, you look up here, like if you want to modify these things, it's easier to just type up here. So I'm going to close the parenthesis there. Okay, -1.6, that looks right. But then if I carry down, notice I'm still getting issues because notice I want to take A2, subtract the mean from F4, and then divide this by the standard deviation, F5. But notice that all of these values are changing. A2, F4, F5, and then A3, F5, F6, A4, F6, F7. We don't want to do that. We want to be subtracting the same value for the mean and the same value for the standard deviation for all of these numbers. So here's what we're going to do. Click on your formula. So we want to hold the mean in place, F4, right? F4 is where our mean is. So what we can do is like right in front of that F, put a dollar symbol, and then put a dollar symbol in between the F and the 4, and then do the same thing for the standard deviation. So dollar symbol here and a dollar symbol here. And now, whenever I drag this down, the formula is correct for all of these values. So these dollar symbols are just locking these numbers in place. So you can see that the A values, so the miles per gallon, A2, A3, A4, those keep changing if you look up here in this formula, A2, A3, A4. But notice that the F4 and the F5 don't change. And that's because we put the dollar symbols around that, which is what we want because we want to keep these two numbers in place. Okay, then we wanted to determine if there were any outliers. So we know that potential outliers are here. Let's first, I don't want so many decimal places. Let's highlight this column. I'm going to do number. Let's go ahead and center that. Okay. Z-scores either less than -2 or greater than 2 are potential outliers, and then values less than -3 or bigger than +3 are definite outliers. Okay, so -1.61 is our smallest number, so that's not an outlier. So now let's go to the top. So notice that we have two numbers that are greater than 2. So we have two potential outliers according to z-score. So I'm going to go ahead and merge and wrap that. Okay, I think we answered everything we wanted to. Let's just make sure. Mean and standard deviation, 5-number summary and box plot, range and interquartile range, z-score, and outliers. Okay, let's see. I'm just going to go ahead and keep going. Let's do number 8. So get rid of this highlighting. Okay, so using miles per gallon and horsepower from problem 5, calculate the covariance, standard deviation of miles per hour. I keep switching this to miles per hour, miles per gallon, standard deviation of horsepower, and calculate the correlation. And then we want to add a trend line to that scatter plot. Okay, so let's create another tab. So I'm going to go down here to new sheet. And then I'm going to move it all the way to the right, retitle it 8. So let's go ahead. Oh, you know what? I'm sorry. Let's not do that. Okay, I'm going to delete this. I'm going to Okay, just ignore this for now. My Excel's not letting me delete this at the... Oh, there we go. Okay, instead of making a new tab, let's just create a copy of tab 5. Because we already have the scatter plot, and we want to calculate the correlation between miles per gallon and horsepower. So let's right-click on tab 5, click on Move or Copy, click Create a Copy, take this down to the bottom, click Move to the end, and OK. Okay, now we have a copy. So now I'm going to title this 8. All right, how about let's go ahead and grab the data for these two. So we want miles per gallon and horsepower. So I'm going to go to the data tab. Let me copy miles per gallon. So copy, paste, and then let me get horsepower. Copy, paste. Okay, and using this data, we created this scatter plot in one of the earlier videos. Okay, but now we wanted to calculate the covariance, the standard deviations, and the correlation. So let's start with covariance. So this is going to be equals covariance. So we'll do covariance.s. If you have, for any of these functions, if you have a .p and a .s, always go with .s. So we want to first select one set of data. So let's do miles per gallon, comma, and now let's select our second set of data. And then let's close our parenthesis and hit enter. Okay, and we've got our covariance. Now let's do our standard deviation of miles per gallon, and then we'll do standard deviation of horsepower. We already know how to do this, so this is going to be equals standard dev, so stdev.s, this one. Let's go ahead and select miles per gallon. Okay, 6.02, that should be the same as the other tab. 6.03, okay, we've got a rounding thing, yes, 6.03. So now let's do the same thing for horsepower. Standard deviation.s, horsepower. All right, and now we can do correlation. Recall correlation is the covariance divided by the product of the standard deviations. So I can do equals covariance divided by, now I'm going to open a parenthesis, because remember, whenever we're dividing things and multiplying it, you should always use parentheses. So let's do standard deviation times the other standard deviation, close parenthesis. So I have the covariance divided by the product of the standard deviations, enter. We get negative 0.77. But we could have also done it just directly using the function. So just like covariance, let's do equals correlation. So CORREL. and let's select miles per gallon, and then comma, horsepower, close parenthesis, enter. And we get negative 0.77. Now, does this make sense? Do we have a negative correlation? Well, yeah, we see that as horsepower increases, miles per gallon goes down. As miles per gallon goes up, horsepower decreases. So there's this negative relationship. When one goes up, the other goes down. Okay, so let's go ahead. I'm going to bold these. I don't like all these decimal places. Okay. Maybe we can even center that. All right, and now we finally just wanted to add a trend line. So let's right click and let's see, how do I do this? Okay, so you actually have to click on one of these data values. So just click on any of the dots and then right click on a dot and do add trend line. And we get a trend line. We can see it's going down. And if the trend line has a negative slope like it does here, it makes sense that we have a negative correlation. And that makes sense, right? The more power a car has, usually is less fuel efficient. At least that's certainly the case back in 1972 and 73. But that's pretty much all we need to do for Chapter 3 Excel Lab. So, all right, that wraps up questions 7 and 8.